So you can see that the array, the array contains some kind of parameter, and the parameter defines the primitive element. So what is the meaning by primitive elements? I give you some of the definition of the primitive element. Let's say if you use B, so it is a signed character. The character, we can have A, B, C, D, and so on. The big B is unsigned character. So unsigned character, is similar with the character, but it is unsigned. Usually we call this is unsigned. It is more free to define the character. We have Unicode character. Unicode character, we can make some kind of symbol. H, big H, I, big I, L, big L, and F, D. So you can look at also the size. So the number of bytes means how big the elements will consume the memory. So if you use D, it will consume 8 bytes. If you use F, it will consume 4 bytes. It means if you use F, it is more efficient. So in this case, it might be if you use a very small number, you can just use F. If the number is too big, maybe you can use D. So it's the same with the long integer and the integer, the common integer. The common integer, maybe the range of the integer is very short, or it's not that long as the long integer. So this kind of code, as I show you. So I define this as the float. Now, if I define this as integer, then it will be error, because the numbers or the element that you define in this array is a float. So you cannot define as integer. So it is very strict to define the data type. And how can you do with the operation with this array? Actually, if I copy and paste this code, it will be the same with the common list. If in the list you want to access the element index 0, then you can just call A0. If you want to access the index 1, then you use A1. If you want to access the index, the ending index or the last index, so you can use A1 minus 1. So the slicing is also working here. Let's say I want to access from 0 until the end. I want to access from 1 until 3. Okay. So we can also do with the common list operation. As you might know, the list is available with multiple elements. Let's say if I have list like this, I can put red, I can put numbers, I can put on product or something. Okay, so I can combine everything in a list. But when you do with array, you need to specify the data type. So we call this is the compact array. Okay, this is another example with the slicing array. So I have this list, and then I put this number list into the array. So I can do slicing. For example, I want to check the element from index 2 until 4, 2, 3, 4. Okay, and then I want to check the index from the starting index until -5. So it means I will start from the last element. I want to start from the index 5 until the end. Or I want to check all the arrays. So this will be the result. Okay. I have another code. Let's say I want to change some element. So I have the array 1, 2, 3, 5, 7, 10. I want to change the first element, which is the index 0, with 0. And then I want to change the element from index 2 until 5 with this number. So it means 3, 5, 7 will be replaced with 4, 6, and 8. So the result will be like this one. Okay. We can also do the operation like in the list. We have append, we have extend. Append. Append means we want to add one value. So if you use append, add one value to the list or array. Okay. So the idea is still the same with the common append. But if we want to extend, it means we want to append iterable to the end of the array. In this case, if I want to add only one value, I will use append. If I want to add multiple values in a list, I will use extend. So if you look at this one, the original list is 1, 2, 3. So I'm going to append a number 4. So I will just use numbers dot append. If I want to extend with 5, 6, 7, so in these multiple numbers, I'm going to use extend. So if you try with this one with append, is it working? Okay, it will be error. So extend will be for only the multiple numbers or a list. What about if I want to remove or I want to delete? In order to delete, you can use the syntax del. So this means I want to delete the element in the index 2. So the element in index 2 means I want to delete 3. Let me just remove this one first. So I will remove 3. The original value is 1, 2, 3, 3, 4. I remove the index 2, which is 3. So now the array will come like this. If I want to delete the entire array, or I want to delete the all elements, so I can just do del number and it will be error, right? Once you delete this variable, you cannot have this variable in the computer. So once you delete this, then it is not available or it is not defined. Okay. Okay, so that's the basic operation for the array in Python. Okay. Now, I would like to give you the basic operation of an array that we can figure out. If you want to make your own array, you can make the class array by yourself. And usually we can think that a class will have at least some operation, for example, insertion. So I want to insert a kind of object. So if I want to insert object O in the index I, so the at I, comma O. Okay. So it is the same with the one that we learned. Oh, we don't have that one. Really, we can also do the insertion. Okay. So if we do it the insert, number dot oh, there's no insert. So if I want to insert in the index 1, and then I want to insert number 3. So in the index 1, now it becomes 3. Okay, maybe for clarity, I will insert 55. So the index 1, now it will be inserted with a new number, which is 1, 55. Now, what does it mean? When we want to add an object or when we want to insert an object, it means we need to make room for the new element by shifting forward the n minus I element. So if I want to insert the object I here, so the remaining will be shifting. In the worst case, when I equals to 0, so if I want to insert a new element in this index, then every element, it will be shifted. So the index 0 will be shifted to 1, the index 1 will be shifted to 2, the index 2 will be shifted to 3, and so on. Okay. So it will be shifted for every element, and the worst case will be n time. So when we do the shifting, it will take, the worst case is n time. So after we shift of every of this element, then I can insert the object code. Now if we want to remove, so we already know how to remove one object. Okay? So we want to remove the index I. Let's remove the index I. In operation remove I, so we need to fill the whole left by the removed element by shifting backward the n minus I minus 1. In this case, I want to delete the index I. So I want to delete this O. After I remove it, then every element in the pink color, it will move here, it will move here, it will move, it will move, it will move. So if I remove the index 0, it means the worst case will be ON. Because if I remove this one, index 1 will be in the index 0, index 2 will be index 1, index 3 will be index 2, and so on until n times. So whenever we do with the data structure, we need to think about these two. Okay. In the array-based implementation of a dynamic list, okay, because this is a dynamic list, because in Python, whenever you have an array, you can enlarge the array automatically. In array-based implementation, you can look at the space. What is the space? It means the number of place that you need to save the element. If we have n elements, of course, the space or the number of storage that we need is also n. Indexing the element at I becomes the at I. Indexing element at I, it takes O1 time. So if I access the array A in index 0, okay, so it will take 1 time. And add and remove run in ON time in the worst case. So in an add operation, when the array is full, instead of throwing an exception, we can replace the array with a larger one. So now I think the Python is very good because when you have an inception, when you have the insertion like this one, I have the array and then I want to append. You can also check the length. The length is 5. Why? Because we have 1, 2, 3, 4, 5. We have 5 elements. Now, if I want to append append, let's say I want to append 6. And what is the length? Now it becomes 6. Actually, in this case, when you have only 5 elements, if you want to add one more, it means you want to replace the array with a larger array. You want to make more bigger array. So the add operation, there will be another operation. Okay. So now we have ON for the add and we have ON for removal. For the space we have ON. And we need to think about the growth strategy. The growth strategy means how to enlarge the array. So the add operation if we don't have any index, if we don't have any index here, it means it will be always added at the end. So this is the same with the append. When we append, it will be always at the end of the list. It will be always at the end of the list. But when the array is full, we replace the array with the larger one. So how large should the new array be? There are two kinds of strategy. The first strategy, we call it the incremental strategy. It is increase the size by a constant c. Or we have the doubling strategy. We double the size. So if we have the add means we want to add an object to array. So we will check first if the t we want to get the length of the s is the array. Then let's make a new array of size n, and then we will start the I from 0 until n minus 1. We will replace for every of this si into the ai. So all the s now will become the a. And the n will be added by 1. So the position n minus 1 will be the object. So this is the overall if you want to make a growable array. Because at the first, as you can see, we have the length 5. So if we want to make the array with the 6, so we need to make a new kind of array. We want to grow it. So we want to grow A. So after we grow the A, so we will replace S with the new A, and then the S at the ending index will be the new object, which is O. We can do this one, but yeah, this is just adding by 1, adding by 1, adding by 1. There are two strategies that I mentioned to you. The first is incremental strategy. It is by C constant, or we have doubling strategy. So doubling strategy, yeah, we will make double. So we can analyze the time. How big is the time needed to perform a series of n at O operation? So we assume that we start with an empty stack represented by an array of size 1. So maybe in the first time, we will have the array of size 1, this one. And then after we have this size 1, we will do the experiment. If we enlarge, okay, if we add a new object, 0 and 1, what is the time? And then we enlarge again, 0, 1, 2. So what is the time? And so on. We call amortized time of an add operation. So this is amortized time. It is the average time taken by an add over the series of operations. So the total time, Tn, will be divided by n. If we use the incremental strategies, it means if we have the array, I have k, it will be equal to n divided by c. Then n means how many numbers that we want to add, and c is a constant value to enlarge theory. So the total time Tn of a series n at operation is proportional to this one. So if I want to add n items, and then whenever I do the growing with the incremental strategy, so I will do, the first will be constant C, the next will be 2C, the next will be 3C, the next will be 4C, and so on until we have KC. And we know that this is a sequence C plus 2C plus 3C plus 4C until KC. We can simplify with this one. C multiplied by 1 plus 2 plus 3 until K. And if we have this sequence, so you can think that this is the arithmetic sequence. If this is the arithmetic sequence, 1 plus 2 plus 3 plus K, it will be equal to this one. 1 plus 2 plus 3 plus K, it will be equals to K multiplied by K plus 1 divided by 2. So we can have this formula. The total time will be n plus ck multiplied by k plus 1 divided by 2. Since c is constant, okay, as you know, when we do the big O, we can just remove the constant. Then we will have only n, which is the number that we want to add, and then we have k. K is the element that we want to grow the strategy. If we have this number, it means we can simplify to n plus k power k multiplied by k plus 1. It means k multiplied by k plus 1 equals to k power of 2 plus k. K power of 2 plus k. If we want to do the big O notation, we can select the higher order. We can remove the lower order. So we don't need the lower order. Then the operation will take n plus k power. So if we have n plus k power of 2, let's look at this formula. K, we replace k with n divided by c. C is a constant. Then we can replace this as n plus n power of 2. Let's assume c is a constant, then you can just say that c equals to 1. So k will be equals to n. And if k equals to n, then I can have the formula n plus n power of 2. If we have n plus n power of 2, then it will be O n power of 2. So the amortized time of an add operation is On. Why? Based on the definition, the amortized time is the Tn divided by n. So we have the On power of 2. It means the operation is n power of 2. This one n power of 2 divided by n. N power of 2 divided by n, then it becomes On. So the amortized time of the add operation will be 1. Okay, so this is the definition of the amortized time of an add operation is the average time taken by add over the series of operation. But when we do with the doubling strategy, okay, what is the meaning by doubling strategy? The double strategy, we can replace k with log base 2n times. Why it is log base 2n times? Let's see. I have n. Okay. N is the number that I want to add to the array. So when I want to add this one, there will be n add operations. And for the series, when it is doubling, every time I add, there will be a double. So the first operation may be 1. The second operation, I make it double. The next operation, I will make it double from the previous one. The next operation, I will make it double, and so on. So it is the geometric series. Okay. The previous one, it is the arithmetic series. This one is arithmetic series. This one is the geometric series. When we have this geometric series, we will end with 2 power of k. 2 power of k, and yeah, we have the k. This is the array at the k position. So we will do the geometric series like this one. So it is 1 plus 2 plus 4 plus 8 plus blah 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 plus 2 power of k. It will be the same as the 2 power of k plus 1 minus 1. Okay. So this is from the geometric series. Because we already have this solution, okay, n plus 2 power of k plus 1 minus 1. We can replace k with the k equals to log 2n. If we replace this one, it means 2 log 2n. What is it? We can just consider this. We can just consider this as 2n. So we will have n plus 2n minus 1. At the end, we have 3n minus 1. So the Tn will be 4. The amortized time of an add operation is O1. Because the amortized time is Tn divided by n. This is n divided by n, then it will be 1. It means with the doubling strategy analysis, whenever we do the addition, whenever we add an object to the array, it will take a constant or O. So which one is the best? If we do with the doubling strategy, it will be the best one because it will be always constant. So the author of the book, they give a dynamic array. Let me check the code. I give you the code in the materials. In the array, you will see the IPYNB. Okay, I give you a lot of examples like this one. If you use the common list, okay, if you use common list, you can do with many data types. You can use integer, you can use float, you can use string. If you use tuple, yeah, you can use also with multiple data types. Integer, float, string. If you use the list triangle, so it is a string, then you can get the character, okay, for every of the element. If you use the array like this one, then you need to define the I. Okay, so I think you already know what this one. Yeah, what I want to explain is this dynamic array. You can make your own array by specifying the dynamic array. This dynamic array, it is a class, and then we can make the constructor. So the starting of the array will be 0, the capacity is 1. Okay, we start with the capacity 1, and then we want to make the array. So we can look at the length, we can get a particular index. It means, yeah, we want to get the k. K means the index of that array. We can append. Append means we want to add one object to that array. So if we want to add this object, so you can see here, if the n equals to the capacity, then we can resize. Resize means, as you know, when we do with the doubling strategy, the array, the add operation will be O1 or constant. So we can use the doubling strategy. So if it is the same with the capacity, we double the capacity. So the A will be, the A in the index n will be the object that we want to add, and then n will be added by 1. So resize, resize means if we have a bigger array, so we can, resize means we put all the old array into the new array with a bigger size. So this is the function. To make array, this is the lower array. This is just to put the array in the memory address. Insert. Insert means I want to insert a particular object into a position. So this is the way to input the object into one position, in this case K. Remove. So it means I want to remove a value in the array. So you already know how to insert, you already know how to remove, and actually behind this array, this is the code. When you do the remove, this is the code. Okay, what is this? Okay, I don't know what this. Sorry, maybe I missed something here. Okay. Yeah, you already learned about the array, okay, and some types of operation, and you already learned also the provable array.